Hello and welcome to Linear Approximation with Elliot Cohen. Today I'm going to teach you how to properly use linear approximation. We're going to start off with an example. Example number 1. Find the linear approximation to the given function at the given point. We're given f of x is equal to 2 to the x at x is equal to 3. The first step we're going to want to take is by providing the point slope form, which is y minus y1 is equal to m, which is the slope, times x minus x1. The second step that we're going to want to do is we're going to want to provide, or what I like to do is provide the f of x again, and then find the derivative of f of x. So that would be f prime of x. F prime of x is equal to 2x times ln of x. This is due to basic calculus rules. And then what we're going to want to do from here is find f prime to the third, which is 2 to the third times ln of 2. From there, we're just going to want to simplify, and we get f prime of 3 is equal to 8 times ln of 2. Now this is just our slope. What we're going to want to do with this, our slope, which is m, is plug it back into the point slope form. So we know that y minus y1, which in this case is 8, is equal to the slope, m, 8 times ln of 2 times x minus x1, which is 3. From there, simplify a little bit, we get y is equal to 8 ln of 2 times x minus 24 ln of 2 plus 8. When we plug this into a calculator, we get that x is equal to 3.11, and that is our linear approximation for f of x is equal to 2 to the x at x equals 3. Some commonly missed mistakes that you're not going to want to make when you solve this problem are getting point slope form wrong. A lot of people use slope intercept form. While that is good, it's a little tough when using linear approximation, because with linear approximation, when you get down to plugging in m, it's much easier just to put the y1 and x1 values, since you're given them, which is 8 and 3 in this case, right into the equation, and then getting slope intercept form to graph it. So I would recommend starting with point slope form. Another commonly missed mistake is not finding the x value at the very end, which is your linear approximation. A lot of people think that, oh, just the equation is alright. Well, you actually want to find this x value because that is your approximation at the given function at the given point, which is x is equal to 3.11, which is only a difference of 0.11 to the given point. Alright, we're going to move on to example number 2. Now, just some more practice. Example number 2. Find the linear approximation of square root of 9.11 when f of x is equal to square root of x. So the first step that you want to take, or that I took, is you just want to find the approximation. So you want to plug in just 9, because it's only a difference of 0.11, into the function, and you get square root of 9. Square root of 9 is equal to 3. From there, you can find the derivative of f of x, so f prime of x is equal to 1/2 times x to the negative 1/2. From that, you simplify, you get f prime of x is equal to 1 over 2 square root of x. You get y prime is equal to 1 over 6 once you plug in 9 as x. So it should really be written as f prime of 9 is equal to 1/6. Once you get the m, or the slope, now you can plug it into the point slope, or into the slope or point slope form. So y minus y1 is equal to m x minus x1, as we did in the previous problem. And then we just plug things in. So y minus y1, which is 3, is equal to the slope, which is 1 over 6, times x minus x1, which is 9. Simplify a little bit, you get y minus 3 is equal to 1 over 6. And now what you want to do when you simplify is you want to plug the 9.11 in as your x, because you're trying to approximate it at that value. So 9.11 minus 9 is equal to y minus 3 is equal to 1 over 6 times 0.11. Add 3 to each side. You get y is equal to 1 over 6 times 1.11, or 0.11 plus 3. You get y is approximately 3.018. So, since we found the linear approximation, which is y is equal to 3.018, we can then infer that the square root of 9.11 is approximately 3.018. Now, one of the biggest common mistakes on this problem is when you get down to y is about 3.018, most students don't understand that what you're originally trying to find is the linear approximation of 9.11. That would be the y value. So you really have to make sure that you connect it here and say that the square root of 9.11 is approximately 3.018. Another commonly missed mistake that I missed on the first time is I wasn't sure what this x value was. Since you're trying to find the difference between the 9.11 and 9, which is a little easier to solve, you want to find the difference between here, which is 0.11. If we were to look at this on a graph, it would look a little bit something like this, where the curve is like this, and you're trying to find the linear approximation at this point. Hope this helps you out, and you learn a little bit more about linear approximation. Until next time.